Hello and welcome to this e-module on Heating, Ventilation and Air Conditioning Part 3 Ventilation. Let's take a look at the learning objectives of this module. By the end of this module, you will be able to understand ventilation and why we need them, understand air handling unit, that is AHU, and why we need them, explain the working principle of an AHU, list the components of an AHU, list the types of an AHU, explain how outside air is supplied for ventilation, describe variable air volume, that is VAV, describe ventilation scrubbers, list the indoor air treatment equipment, explain the working of exhaust fans, explain the working of jet fans, list the original equipment manufacturers, list the parameters to be recorded for AHUs, list the maintenance checklist for AHUs, explain the service levels to be maintained, understand the preventive measures to be taken, explain the impact of improper maintenance of AHU or associated equipment on businesses, list the top issues and troubleshooting tips. Before we begin, let us take a quick recap at what we have learned so far about HVAC systems. As we learned in the earlier modules, the comfort of occupants in office spaces is fundamentally influenced by the thermal and air quality. HVAC systems are designed to provide workers in office buildings with a suitable air temperature, humidity, and quality. We saw that HVAC systems can vary greatly in complexity, from small standalone units that serve individual rooms to large centralized systems serving multiple zones in a building. In the previous module, we learned about the central air conditioning plants, namely chillers and the cooling systems, and how they chill water and distribute it across the building for cooling of the air. In this module, we will learn about the methods and equipment of the ventilation systems using which the air is cooled and distributed within the facility, and also how fresh air is added to the system while removing the stale air. Let us now learn about the ventilation systems in detail, starting with the air handling units, that is AHU. The primary and the major source of providing cooling indoors for the central plants is the air handling units AHU, which act like an evaporator and use the chilled water to cool the air passing through them. The cooled air is distributed across the floor through ducts and vents or diffusers located in various areas. In order to control the flow of air, dampers are used. There are systems like the variable air volume, which can adjust the flow according to the needs. Variable speed drivers also help in controlling the flow from the AHU. Why we need ventilation? Well, we all know that fresh air is one of the most important preconditions for life itself. However, all air contains pollutants to different degrees depending on time and place. Most people across the world spend as much as 80% of their time indoors. It is therefore important that the air they breathe is fresh, free of pollutants, and healthy. People feel better if we have clean air to breathe and become more productive and perform better, whether it is at work, in school, or at home. The number of sick days also go down if the air quality is maintained. It is therefore evident that the air inside the facility is constantly recirculated while being cooled and cleaned, and also that some fresh air is added and the stale air replaced. Let us now understand more about air handling units. An air handling unit AHU is used to condition and circulate air as part of a heating, ventilating, and air conditioning system. The basic function of the AHU is to circulate indoor air, add fresh air to it, and condition it to the right temperature and humidity before delivering it back to the conditioned spaces. The air handling unit packs multiple functions into one unit. and with the help of supply and return air ducting, circulates the air in the facility floor. The AHU has filters for cleaning the air, humidifiers and dehumidifiers for humidity control, a heat exchanger which cools the air, and a fixed or variable speed fan to push the air back into the conditioned space. The layout of the ducting is designed in a manner so as to distribute conditioned air to optimally cool all areas. The ducting may also be insulated to prevent the sound of the running AHU motor and flowing air come into the work areas. There are other ventilation systems which may be used in the facility in addition to AHU. Systems like treated fresh air units, that is TFA, scrubbers, VAVs, dampers, etc., which are used in conjunction with the AHU, and standalone systems like exhaust fans in washrooms and kitchens, jet fans in parking, etc. These will also be discussed in this module. Do you know why we need AHUs? Let's understand. Air handling units are in use across a diverse range of applications and sectors, including hospitals, clean rooms, universities, laboratories, office ventilation, retail, hotels, data centers, server rooms. They maintain certain levels of human requirement of air quality in these areas that include particulate and odor filtration, noise, and fresh air supply. As already discussed earlier, the AHU is also used to control the following parameters of space in the buildings: temperature, humidity, air movement, air cleanliness. Now that we have understood the need for AHUs, let's understand their basic working principle. The air handler of an HVAC system is connected to a network of ducting with diffusers or grills at the end user side. The supply air ducts supply the cool air from the AHU to the conditioned space, and the return air ducts suck the used, normally warmer air from the conditioned space and send it back to the AHU. A single blower is used for the circulation purposes. When the blower pushes the cool air into the supply ducts, it creates a vacuum in the plenum, that is, the open area above the AHU, which sucks the used air through vents in the return air ducts. Ideally, the flow in the supply duct should match that of the return duct to maintain the pressure in the conditioned space. In most systems, the blower is a squirrel cage fan that simultaneously creates a vacuum to pull air out of the room and pressure to force it through the ducts. The running blower in the AHU sucks in the return air from the plenum and also some amount of fresh air from outside, usually controlled by a damper. The return fresh air mix passes through filters in the body of the AHU. The clean air passes over the chilled water pipes and gets cooled before being pushed by the fan into the supply ducts for distribution in the conditioned spaces. The cycle repeats continuously. The deliberate entry of fresh air serves two purposes. One, the requirement of maintaining the quality of air, and the other is to replace air lost through openings and exhausts in the floor. This also ensures that the insides are maintained at a slightly higher pressure than the outside, so that the untreated outdoor air does not come indoors through the openings. Next, let's look at the components of an AHU. An air handling unit will at a minimum have at least one filtration section, a heat transfer component, that is cooling or heating coil or heat recovery system, a fan. The air handling units can have several components depending on the complexity and requirements, such as energy efficiency of each specific building and application. Typically, an AHU will have housing, air mixing section, blower section, filter section, heat exchanger section, heat recovery systems, humidifiers, dehumidifiers, dampers, and ducting accessories. Now, let's look at each one of these closely. The housing contains all the other components of an AHU, comprising of a metal base frame held together by an extruded aluminium framework. The panels are made of repainted or pre-coated or GSS sheets injected with environment-friendly PUF of uniform density. The panels are fixed to the framework using special imported self-drilling and tapping screws. PUF or polyurethane foam is used to insulate the panels to prevent the condensation on the panel. A drain pan is also provided to drain the water in the event of condensation of water. Fresh air and return air can be mixed at the desired rate with dampers that are specially designed for maximum air efficiency. Motorized or manual damper in extruded aluminium aerofoil design or GSS or SS construction is available. A combination of two-way or three-way mixing chamber is also available. The blower or motor fan is another component of the AHU which helps to recycle the air present in the buildings. Large AHUs can have multiple blowers and fans to condition the air. Air in the building is pulled by the blowers and conditioned. It is then released into the buildings. There are various conditioning elements used to heat or cool the air. Heating coils are used to heat the air in the heating systems. Air conditioners use cooling coils to condition and cool the air. The fan and motor is normally mounted on a common channel fitted with anti-vibration isolators to avoid the vibration transfer to main casing. Filter section. Filters include plate filters, bag filters, compact filters, EPA filters, HEPA filters, ULPA filters, and carbon filters. Filter section is fitted in all the air handling units which help to filter the impure air. It is one of the most vital components of an air handling units. It is quite important to clean the air present in the rooms to remove dust and other foreign particles. The presence of filters helps to extend the durability of these units. Filters are rated by their MERV, that is minimum efficiency reporting value, and the selection will depend on the particular requirements of level of cleaning required. In some AHUs, UV filtration may also be implemented for getting rid of bacteria. The heat exchanger section will comprise of the cooling or heating coil is used to cool or heat and dehumidify the air. Both DX, that is direct expansion cooling, CW, that is chilled water cooling, steam, electric gas-fired coils are available for use depending on the system design. As we learned earlier, in case of central ACs, the chilled water is used as a refrigerant. The coils are arranged in rows with different fin spacing. Aluminium fins and copper tubes are used in the design of the coils. In some AHUs, heat recovery systems may be used which typically incorporate heat exchange equipment to reduce energy costs by extracting heat from the facility's exhaust airstream before it is vented outside. These systems include cross-flow plate heat exchangers, heat wheel or rotating heat exchangers, run-around coils and heat pipes, etc. During winter, the humidity level of the air can be low, hence causing discomfort to the occupants. The humidity of the air is increased by using the humidifiers. Types of the commonly used humidifiers are as follows. Spray type has a header and spray nozzles that spray water with a pressure of 15 psi or more. Steam pan type has a pan and a heating coil to heat up the water of the pan. The evaporation of water caused by the heating will increase the humidity level of the surrounding air. Steam grid type has tiny holes on the pipe to distribute the system that flows through it. In this case, the water that is heated up to produce the steam to be supplied to the grid is conditioned to prevent odor being discharged to the room. The correct level of humidity is crucial for an optimal room climate. Experts agree that a minimum of 40% relative humidity is essential in order to guarantee a room climate that is both healthy and comfortable. Normally, the cooling of air takes away most of the moisture, but in places with high humidity, some additional measures may be required. The dehumidifiers can work either on a spray principle or use a desiccant method. Dampers are devices which permit modification of the air resistance of the system and consequently a change in the airflow rate or complete shut-off of the airflow. Air dampers are designed for regulating airflow in rectangular or circular ducts. The dampers are at times also connected to the fire alarm panel to automatically shut off in case of fire and thus stop the flow of the air into the conditioned space. We talked about vents and diffusers earlier for delivering the cool air and also allowing the return air to reach the AHU. The different types of accessories that you might come across in a ducting system are shown on your screen. Now, let us look at the classification of AHUs. AHUs can be classified based on how they are mounted, that is, horizontal floor mounted, vertical floor mounted, or ceiling suspended. AHUs can also be classified based on where the fan is located with respect to the cooling coils, that is, draw-through type and blow-through type. In the draw-through type, the fan is located towards the discharge side and pulls the air through the filters and cooling coil before discharging it from the fan outlet to the ducting network. In the blow-through type, the fan blows the air through the filters and cooling coil before discharging them to the ducting system. In order for the ventilation systems to keep the indoor air clean and fresh with sufficient oxygen, it requires a constant supply of fresh outside air to replace the indoor contaminated air. Let us understand how this is taken care of. The air vented from the facility by exhaust fans must be replaced by outside air. This can be done from air leaks, from inlet vents, and via ducted makeup air. Let us know more about each one of them. In small facilities where humidity is not a big concern, this new air comes into the facility through air leakage. Relying on air leaks requires no extra equipment. However, the occupant has little control over the air entry points. In larger facilities, it is desirable to restrict the entry of air through leaks and utilize a fresh air intake instead. This ensures a positive pressure in the facility which will not allow the outdoor air and contaminants to come into the facility without any treatment. Providing fresh outside air through inlet vents is another option. They are usually located in exterior walls. The amount of air they allow into the facility can be controlled manually or by humidity sensors. Locate inlet vents where they will not create uncomfortable drafts. Outside air is drawn into and distributed through the facility via the ducts for a forced air heating and cooling systems. This type of system usually has an automatically controlled outside air damper in the return duct system. The blower for the ventilation system is either the air handler for the heating and cooling system or a smaller unit that is strictly designed to provide ventilation air. A slight disadvantage of using the HVAC blower is that incoming ventilation air may have sufficient velocity to affect comfort during cold weather. The return ductwork for the heating and cooling system may be connected to a small outside air duct that has a damper which opens when the ventilation fan operates. Special controls are available to ensure that the air handler runs a certain percentage of every hour, thus providing fresh air on a regular basis. The number of air changes required in the facility is specified by guidelines issued in national standards and needs to be confirmed too. The ventilation system or the fresh air intake is designed according to these guidelines. In this section, we will now look at the other ventilation system components that aid in the maintenance of the air quality. Let's begin with the variable air volume, that is VAV systems. When the space to be cooled is large, such as an auditorium or open factory floor, the HVAC system delivers tempered supply air based on a single set point, and space temperature through various diffusers. This method of distribution, referred to as zone control, however, is not suitable for situations when the system must maintain the comfort level in several zones and the problem becomes more complex. For example, an office area system must maintain a comfortable temperature based on multiple set points in individual rooms. Variable air volume (VAV) is the de facto solution to these more complex scenarios. Variable air volume, that is VAVs, are used on the ducting system for temperature control and are characterized by a supply airstream of constant temperature, a modulation of the amount of air that serves a particular space. VAV is the most common method employed in commercial or institutional buildings and is both an effective and economical means of temperature control. However, please note that VAVs control the flow of volume of air, and hence it is important that the AHU motor is also of variable speed in order to maintain the pressures in different zones. The simplest VAV system controls air from a single supply duct and varies the airflow to each zone or room based upon the temperature in the room. From a control perspective, such a system would consist of a few essential components: temperature sensor, airflow sensor, controller, actuator, damper. In some instances, these components are combined. For example, a smart thermostat can combine the functions of a temperature sensor and a controller. Simply, a VAV combines the functions of a controller, actuator, and airflow sensor. Next, let us try to understand the working principle of a VAV system in greater detail. When the temperature sensor determines that the space temperature is at set point, the controller closes the damper until the airflow reaches a predefined lower limit. As the room temperature moves away from set point, the controller opens the damper until the airflow reaches a predefined upper limit. If the room is at the temperature set point, the damper in the VAV closes to minimum airflow. As room temperature rises above set point, the VAV controller opens the damper to introduce the cool supply air into the room, which returns the temperature to set point. The exact position of the damper varies between minimum airflow and maximum airflow as the requirements for cooling in the room change. In VAV systems, the stream of tempered air is supplied by an air handling unit, that is AHU, to a network of VAV units. The AHU must be able to respond to the fluctuations in duct pressure caused by the individual VAV dampers constantly opening and closing. In addition, it must meet the various demands of individual VAVs. The dampers are motorized and hence do not require any manual intervention. Next, we will have a look at ventilation scrubbers. A scrubber is essentially an air pollution control device used to remove particulates or contaminants from the air. From the specific purpose of HVAC, the scrubber is used to clean the outside air before being fed into the indoor HVAC system. It does this by use of a pre-filter for removal of dirt and dust contaminants and a special activated media which uses absorption for capturing the gaseous contaminants. Both the absorber and pre-filter are enclosed together in a steel housing. Air scrubbers are commonly used in facilities where the outdoor air quality is not good. In such areas, it becomes necessary to clean the fresh air being taken in to ensure the air changes within the facility. This could include areas near the coast, landfills, etc. The air scrubber provides for the treatment of fresh air before it gets into the indoor areas of the facility. Next, let's learn about air purification systems used in industries. These systems are ideal for cleaning fresh air intake from areas with hazardous contaminants like CO or other industrial gases. They are self-contained multi-stage units for continuous purification of toxic odorous, and corrosive industrial environment. Air purification systems can be categorized as using PIA, potassium impregnated alumina, filter bank, activated carbon filter, micronic filters. Now let's understand about the use of exhaust fans in facilities. Exhaust fans are required in places like washrooms and live kitchens to take the adulterated foul air away from the facility. These are regular fans sucking air from the inside and throwing it outside. The exhaust fans would normally be installed on the wall facing the outside environment open directly into the atmosphere. The washrooms or any other room having exhaust fans should also have a grill built into the entry door, because otherwise it would put additional load on the fan to throw air out and also create a negative pressure inside the room, which will lead to a high draft when the door is opened. The size or rating of the exhaust fan will depend on the size of the room and the traffic in the room. Another type of fan used for the purpose of ventilation in facilities is the jet fans. Let's learn more about them. Jet fans are used to ventilate and extract smoke from enclosed or underground car parks and basements. Jet fans provide the ability to ventilate and extract smoke without using any ducts, resulting in tremendous cost savings, power savings, and increased installation efficiency. Jet fans can be used for normal ventilation and also for smoke extraction in case of emergencies or a combination of both. The parking spaces, unless properly ventilated naturally, end up with a lot of vehicle exhaust containing CO and CO2. Therefore, to prevent higher concentrations of these gases and avoid a fire risk, jet fans are used to systematically remove these gases out of the spaces by directing the same at high speeds. Multiple jet fans positioned appropriately and directing the air out can take out the contaminating gases efficiently out of the parking lots. Next, we will have a look at the manufacturers of the major equipment covered in this module. Let's begin with AHUs. Top manufacturers, air handling unit. Top 5 manufacturers of AHUs are Carrier, ETA, Blue Star, York, Blue Box. Top 5 manufacturers of VAV are Johnson Controls, Zico Aircon Limited, Bellino, Blue Star, Tuttle and Bailey. Top manufacturers of jet fans are WITT Private Limited, Flowline India, Green Heck. Top manufacturers of scrubbers, Waves Aircon, Ventex Systems, Airflow HVAC Systems, Zico Aircon. Top manufacturers of TFA are Zico Aircon Limited, Zico Aircon Industries Private Limited, Waves Aircon, BRY Air, Bry Air. Now, let's have a look at the maintenance checklist of AHUs. Maintaining the air handling unit AHU is crucial to the HVAC system's functionality. The heating and air conditioning system's air handling unit is the central unit that moves air throughout ductwork. A malfunctioning air handling unit usually experiences problems when certain obstructions are blocking airflow. Due to the large size of the units and lack of space, the AHUs do not have a redundant element, and hence, if one goes down, the load will come onto the other AHUs on the floor. Here are a few points to be checked on a regular basis. Check your air dampers. You'll need to make sure your system's air dampers are opening, closing, and modulating properly. To allow for changes in outdoor airflow, sometimes air dampers actuators need to be installed. They will keep your dampers modulating effectively. Check heating, cooling coils and valves. To ensure the proper operation of your heating and cooling valves, you will need to determine if it's seated correctly. If the valve placement is off, your HVAC may be unnecessarily heating and cooling simultaneously. This could get very uncomfortable for your employees. You can check the HVAC's air mixture and discharge temperatures by shutting off the valve. If it's shut off and the supply is still heated by the coil, the AHU's valves are malfunctioning. To check the cooling coils, you'll need to check their cleanliness. If they are covered in dirt, dust and debris, wipe them down with a clean cloth. Dirty coils increase static air pressure, causing increased fan energy waste. More air is needed to flow over a dirty cooling coil in order to elicit the same heating and cooling effects. Assess the status of the air filters. Static pressure sensors are used to determine how dirty the air filters are. Unclean air filters waste your facility's energy. The fan system needs to work that much harder to account for airflow obstructions. The air filters should be changed as soon as possible if they aren't slightly opaque. Ensure the proper operation of your air side economizer. Some HVAC systems have air side economizers that have outside air temperature sensors and outdoor relative humidity sensors that need to be operating properly. Your economizer functionality can be assessed by viewing damper positions and outdoor airflow rates. Let's look at the checks that should be done on a daily basis. Check air filter clogged or not. Check AHU inlet and return air filters Magnehalic gauges. Check chilled water inlet or outlet valves. Check chilled water inlet or outlet temperature gauges. Check chilled water inlet or outlet pressure gauges. Check chilled water strainer clogging or not. Check motor and blower for any abnormal noise and vibration. Check AHU door limit switch. Check AHU light. Check UV lights. Check actuator functionality. Ensure drain line is not clogged. Check chilled water pipe insulations. Check AHU and AHU room for cleanliness. Some electrical and mechanical inspection of equipment should be done on a monthly basis. Let's begin with the electrical inspection checklist. Ensure LOTO is applied. Check all electrical cable connection tightness in motors. Check earthing connection of motors. Check the limit switch and internal light function. Check UV light for healthy condition. Check fire damper controller. Clean electrical panel with blower. Now let's look at the mechanical inspection checklist. Clean supply air filters. Clean HRW return air filter. Check pulley V-belt deflection. Inspect belt and change if required. Check for all bolt and nuts for tightness. Check all inlet and outlet pressure gauges. Check all the valve operations. Check all inlet and outlet temperature gauges. Check gauges functions. Check cooling coil for any damages. Check all the VCD are working normally. Ensure condensate drain line is not clogged. Ensure cleanliness of area after completion of job. Next, let us understand the service levels that need to be maintained for AHUs. Fully operational availability of AHUs at all times. Maintenance is carried out as per plan and OEM recommendations. Switching on or off as per laid down schedule. Cleanliness of AHU room or unit. Ensure no water is collected at any time. Some preventive measures need to be taken for proper functioning of these equipment. Let's understand them. Adjust belt tension so that the belt is tight. Check the condition of V-belt for any crack. Replace if required. Check the tightness of the pulley and alignment. Check for any abnormal noise or vibration and tighten fastener if required. Check the drain tray for any clogging. Clean return air filter and fresh air filter if any. Clean AHU. Check the operation of the control devices like thermostat or humidistat. Check the operation of the mixing valve. Inspect blower shaft, bearings and scroll of AHU. Check the starter panel or BMS controller panel as per its checklist. This will form a part of this report. Check the condition of the thermometer and pressure gauge. Lubricate damper linkages and check damper motor. Clean the coil with hose of air jet once in a year. Check the coil fins for damage and for any corrosion once in a year. Next, let us look at the issues that can arise due to improper maintenance of AHU or associated equipment, which might lead to occupant discomfort. Uneven air distribution throughout the office. Air stratification dead zones resulting in hot and cold spots in a room. Excessive noise generated from the air handling unit from restricted airflow. Annoying vibration from fans. Inefficient operation. It should also be remembered that at most facilities there is no redundancy built into AHUs and hence if one fails, the area being served will be severely impacted. Even where multiple units on same floor are there, failure of one unit will lead to overall drop of efficiency in all units. Lastly, we will look at the top issues associated with AHUs and related equipment that you may encounter and some troubleshooting tips to address those issues. That brings us to the end of part 3 of this module on HVAC. In this module, we looked at the need for ventilation, the need for an AHU, the working principle of an AHU, the components of an AHU, the types of an AHU, supplying outside air for ventilation, variable air volume, that is VAV, ventilation scrubbers, indoor air treatment equipment, exhaust fans, jet fans, original equipment manufacturers, OEMs, parameters to be recorded for AHUs, maintenance checklist, service levels to be maintained, preventive measures, impact on business, top 5 issues or troubleshooting.